So what I want to do in this video is go through the step-by-step procedure of building on this idea of dummy variables. What are dummy variables? How do we include them? And how can we interpret the coefficients that get estimated from it? So dummy variables and their interpretation. I want to start with the simplest model, the simplest possible model. Simplest model. Imagine that what you're doing is you have a y variable and you just run it on a constant. Okay? So your parameter that you're trying to estimate is beta 0. So your data, well, if you think your x variable is the constant here, this beta 0 is being multiplied by 1, so you can think of this as your x0. So your x0 is simply 1 all the time. The variables that you get, the actual y's, could be dots around this, okay? And now you're going to fit an OLS, okay? So what you're going to try and do is you're going to try and find beta 0 hat. What's going to be beta 0 hat? What's going to be your best guess about beta 0 hat? Well, you can use your first order conditions from the OLS and try and figure out what this will be. But you can take my word for this, without doing the first order conditions, that if you want to minimize the residual sum of squares, the best beta 0 that you're going to find is going to be y bar. So the best beta 0 is going to be at a point y bar is going to be equal to my beta 0 hat, which is the average of the y. Of y. This is the simplest model, okay? Let's add a bit of complexity. Let's add a bit of complexity, and let me tell you that this is actually wage, okay? This y here. Let's add some complexity and let's contextualize it. Let's say this is wage, okay? And let's say that you wanted to do the simple model. So in the simple model, you're trying to explain wage, or y, but now you have beta 0 plus beta 1 times female plus the error term. If you have a model like this, your x0, if you like, it's still 1. So this is 1. This is still my x0. My x1, if you like, is now a dummy variable. Okay. How do I plot this? Well, let's plot it together. Here I'm going to put the wage, or the y. Here I'm going to put the x. Which x? x0 or x1? Well, let me put x1 because x0 doesn't change, so I keep that in the back of my mind. I know that there's an x0, but it's just a constant, it doesn't change over time. How will the data look like? Well, very simple. What value does x1 take? Well, x1 is just a female dummy, so it's either going to be 0 or it's going to be 1. And then I'm going to look at the data. Well, if it's 0, I'm dealing with male, so it's going to look like this. Perhaps this is going to be my data for wages for male. And then in green, I'm going to do wages for female. Okay? That's how the data would look like. That's what the dummy variable will do. We'll subsample your data into male and female. Okay? So all these greens one are females. And all the blues one here are males. Now, think about just geometrically, if you're trying to fit a line that minimizes the residual sum of squares, okay, how would that line look like? How should that line look like if I want to minimize the residual sum of squares? Well, you could do first order conditions here, but you could also visualize it. If you have to visualize it, that line will probably try to get at some point here in the mid of this too. All right, and then it might look something like this. Okay, so if I want to fit a line, it should look like this. This is going to be my beta 0 hat. Okay, because this distance here is exactly 1, then this height here is exactly the slope, which is beta 1 hat. Okay, but graphically, what can you see? Graphically, if I want to minimize the residual sum of square, this point here is going to be my best guess of wages when I'm looking at males. So my best guess of wages when I'm looking at males is the average wage of male. So beta 0 hat is going to be average wage if male. What is beta 0 plus beta 1 going to be? Well, beta 0 hat plus beta 1 hat is going to be equal to average wage if female. How could I have gotten this? I could have also gotten this by simply thinking about it and just saying, what is the expectation? What's my best guess of wage if you are a male? Where if you're a male, this female term disappears and I'm only left with beta 0. So that's going to be my best guess for that. Yeah, let me take your question.
I was just wondering, on this flow graph, where would beta 0 hat be graphically?
So the question is, where would beta 0 hat be grammatically? It will be at the intercept, right? So if this is my OLS fitted line, right? If this is my prediction for wage hat, beta 0 is going to be this height here. Beta 1 is going to be the slope of the line. What's the slope of the line? Rise over run. The rise is the green bit, the run is this, but I know that the run is just 1. So this is going to be beta 1 is going to be the slope. So effectively, what will beta 1 tell me? It's just simply going to tell me the difference in the averages between male and female. Dummy variables are really powerful at doing these things. Okay? Now, let's say that you wanted to add an extra layer of complexity, which I'm not going to be able to draw, okay? I mean, I could try and draw it, but it's going to be very messy. Let's add an extra layer of complexity, and let's say that you wanted to dissect your group into young and old, okay? Let's say that you wanted to say young, 1, if age is below 20. 0 if age is greater or equal to 20. Okay, a lot of you might disagree with the definition of young and old. Okay, but that's out of the scope of this. Okay, so imagine now that I asked you the following. I was doing wages here, and then I did beta 0 plus beta 1 female plus beta 2 young plus beta 3 times female times young. So I'm interacting this. Now everything on the right hand side is a dummy variable, so I can still interpret everything as if they are differences in averages. Okay? I can still interpret everything as differences in averages. But now think about it. How many subgroups will I have? If I have 2 dummy variables, how many subgroups will I have? 4. Female and young, female and old, male and young, male and old. Right? So I can figure all those stuff out. So if I'm looking at female and young, then the average wage of female will simply be beta 0 plus beta 1 plus beta 2 plus beta 3. Agree? All of those will be 1. So I'll just replace the f and the y with 1s. If I want to look at the group 0 and 1, what's going to be this? Well, this will disappear, this will disappear. I will simply have beta 0 plus beta 2. Now, because these are estimated wages, okay? These are my predicted wages. I have to put hats onto those because these are averages. Okay? So the rule of thumb, the main lesson to draw out of this is whenever your explanatory variables, your right-hand side variables are dummy variables, effectively what you're doing is you're looking at different averages of different subsamples and you're comparing them. Okay? That's all you're doing. Right? So what will beta 1 capture? It will capture the change in wage for being female. What will beta 2 capture? The change in wage for being young, for both males and females. What will beta 3 capture? It's an interaction term. It will capture the change in wages when you are both female and young in comparison to the male counterpart. So, in short, dummy variables are really powerful at dissecting the sample into different subsamples. And when you only have dummy variables on the right-hand side, you can interpret everything as differences in means of stuff. Okay. Now, here's a little warning. Imagine that now you had this. Imagine that now you had a non-dummy variable like experience. So you have experience here, you have wage here. So this is another example. And now you have, maybe, let's see, you have a particular group that kind of looks like this, and you have a particular group that kind of looks like this. Well, in this particular shape or in this particular form, it's going to be, you're not going to be able to interpret things anymore as averages of things. So in other words, the right model here would be something that looks like this. Beta 0 plus beta 1 green, if you belong into the green group, plus beta 2 experience plus beta 3 experience times green plus epsilon. You can no longer interpret beta 0 hat will no longer be average wage for blue. Because this introduction of experience, which is a non-dummy variable, you cannot anymore interpret things as changes in averages. But if you only have dummy variables, you can. So that's it. That's my short introduction for dummy variables.